The next example, which is also a very special kind of a sum, that is, the question says if a square is equal to 5a minus 3 and b square is equal to 5b minus 3. Can you see? Yes. Then find the equation whose roots are, how far can I write? Till there. Okay, a by b and b by a. Without solving, mind you. In all the cases, we are not solving the equation. We know we are using the relation between roots and coefficients and we are arriving at the desired equation. Okay, so we have two relations over here. That is, a square is equal to 5a minus 3 and b square is equal to 5b minus 3. So you can see there is some similarity in them, right? So I can say that if I take a general equation in the form x square is equal to 5x minus 3. If I take a general equation in this form, then this equation by question is satisfied by the value a and the value b. Yes or no? You let me to it, I guess. Because you can see if I put x value as a, I get a square is equal to 5a minus 3, which is this. And if I put x is equal to b, then I get b square is equal to 5b minus 3, which is this. So generalizing, I can say that x square is equal to 5x minus 3 is an equation which is satisfied by the values a and b. So that means, what can I conclude? This means that the values a and b are actually the roots or the solutions of the equation, this equation, that is x square, rearranging and writing it in standard form, x square minus 5x plus 3 is equal to 0. Okay, so I can say that a and b are the roots or solutions of the equation x square minus 5x plus 3 is equal to 0. This is the starting point. This is the main part of this solution. Okay, because after this, there's nothing much to do. What you have been doing all this while is what you have to do. Sum of roots, product of roots and all that. Okay, so this is the starting point where you're likely to get stuck. So you have to, this is an observation which you must make. Okay, so we see that the equations have both these expressions have some similarity, and therefore we can say that it satisfies, a and b satisfies this equation. And therefore accordingly, what do I get? Sum of the roots, I will get sum of roots, which is a plus b. It is minus b by a. Okay, this is, be careful, a is 1, b value is minus 5 and c value is 3. If I compare with the standard quadratic, ax square plus bx plus c. So I get this as minus as it is. In place of b, I am writing minus 5 by 1. So the value is 5. Okay. Product of the roots. Product of the roots, which is ab. It is c by a according to the theory that we have learned. So it's 3 by 1, that is 3. So a plus b is 5. This is one relation. And ab is 3. This is another relation that we have obtained. We label them as 1 and 2. They have asked you to find the equation whose roots are this. That means one root is a by b, the other root is b by a. We know equation whose roots are, one root is a by b and the other root is b by a, should be, what should it be? X square minus sum of the roots as the coefficient of x plus the product should be equal to 0. In other words, x square minus, what is the sum of the roots? A by b plus b by a. This is the coefficient of x plus the product. Their product is 0. So what do I have? I have x square minus, it becomes LCM if I take a square plus b square by ab. X, here b cancels, plus 1 is equal to 0, out of which AB value is known. AB value is 3. And A square plus B square can be written in terms of A plus B whole square. That is, it can be written as A plus B whole square minus 2AB. You can calculate it separately and substitute. I am writing it here itself because the expression as such is not very big. So it can be managed. So therefore, what do we have? We therefore have A plus B whole square. So this means equal to x square minus A plus B value is 5. So it is, I'll open the bracket, 5 square minus 2 into AB value is 3 by 3. X plus 1 is equal to 0. So if we take the LCM, it is 3x square minus, how much is this? 25 minus 6, right? 25 minus 6 gives you how much? 19, isn't it? So it is 19x plus 3 is equal to 0, and this is your answer. Okay, so this is the required equation which you have been asked to find. That is, whose roots are A by B and B by A. This part is very much easy to handle. The first part is where is the starting point and where you have to use little bit of intuition. Okay, so